Welcome back, students. In this video we're going to cover Module 10, Topic 3, Arcs and Chords. This is page 4 of the Module 10 packet. In this topic, you guys are going to solve problems involving the relationship between arcs and chords and radii that are perpendicular to chords. All right, so let's do the bell ringer real quick. All right, answer true or false. Number 1, the longest chord in a circle is the diameter. So if you think about this, the diameter goes through the center and it touches the circle, so it's going to be the furthest across, or the longest, and that is true. All right, number 2. If any chord has a length equal to half of the diameter, it's a radius. Okay, so this is going to be false, because you can have a chord that may be equal to half the diameter, which is equal to a radius, but it's not a radius. It can be just another chord. It's a chord. It touches, the chord touches both sides of the circle, where a radius has to touch the center point. All right, number 3. In any circle, the length of a chord AB is less than the length of arc AB. Okay, so yeah, we have that as true. For some reason my brain's not processing that right. All right, number 4. A circle has infinitely many chords of different lengths, and that is true. So if you drew a circle and you made chords, it touched out, it would kind of spiral around. It would look like one of those little spiral paintings. So the answer is true. And then number 5, for any given chord AB in a circle, there is only one chord that is perpendicular to it, and that's false, because you could have several that are perpendicular, because the chord is going to run across and everything in that direction, or if it's this way, the opposite direction, so that one's going to be false. I wish I had something to animate that. I could make that make more sense to you. Okay, we're going to scooch down the page. Arcs and chords. So a chord is a segment with endpoints on a circle. So it touches the circle. Both the ends touch the circle. Okay. If a chord is not the diameter, because the diameter is a chord, because it touches both sides, it just goes to that center point, then its endpoints divide the circle into a major and a minor arc. Okay, so like right here, FG, so it makes a minor arc. FG this way, that's less than 180. And then from here all the way around is more than half the circle. So that's greater than. So again, a minor and a major. All right, so Theorem 10.3 says that in the same circle, or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So for this example, if FG and HJ are congruent, then their chords would be congruent. So the line is this line segment, or the chord, and the arc, so FG, arc FG, is congruent to arc HJ. My terrible writing. So, but notice the arc has looks like a partial circle. Chord is a line segment. But this guy is congruent to this guy, so this guy is congruent to that guy. All right. So if a line, a segment, or a ray divides an arc into 2 congruent arcs, then it bisects the arc. So there's that word again, bisects. It means to cut into 2 equal pieces, 2 equal arcs, or 2, congruent means equal. But, all right, so theorem 10.4. If the diameter or radius of a circle is perpendicular to a chord, so like this guy down here, then it bisects the chord and its arc. All right, so sorry about that. So what that means, so this is your diameter, this is your chord. This means it's perpendicular, right? So if diameter AB is perpendicular to chord XY, then XZ equals YZ. So it splits this thing into two equal pieces, and it splits the arc into two equal pieces. So it would be, so segment AZ, and this arc is XB because this angle makes this arc. XZB makes arc X. So XB, arc XB is congruent to, so this guy is congruent to arc YB. Okay, that makes sense. Okay. All right, scooching down the paper. Gotta finish off the page here. Okay. So theorem 10.5. So the perpendicular bisector of a chord contains a diameter or radius of a circle. So in this case, AB is perpendicular to XY. Then AB is the diameter. So it's just this up here in repeat. So if this was split, this was perpendicular, and these arcs were congruent, then that would make that the AB, the diameter. Yeah, as we've talked about all year, you know, the geometry, they tell you, okay, the angle does this to the side, or in this case the arc, or the chord, and then they'll tell you in reverse that the arc or the chord or the whatever does that to the angle. So just a theorem in its converse. All right, so in addition to theorem 10.3, you can use the following theorem to determine whether two chords in a circle are congruent. So theorem 10.6, in the same circle, or in congruent circles, chords are congruent if and only if they are equidistant from the center. So let's see. So right here, so FG would be congruent to GH. And I'm going to highlight these because it kind of gets a little, the congruent marks kind of get weird. So these guys are congruent, okay, if and only if they're equidistant from the center. So this would be the same distance. So right here be congruent to right here. Excuse me. And that's, we'll just say XL and YL. So XL congruent to YL. All right. All right, so if you watch the last video, you see that I'm gonna do not doing all the work because we're getting a little lazy. You've been working and doing your thing. Congrats, and I appreciate it. To the rest of y'all, shame on you for just pausing and taking the notes, but it's getting close to EOC time, so you guys got to start doing more of the work. So I'm going to do on page 5, we're going to do the I do's. Those are 1 and 3. The you do's are number 2 and number 4. They're on the right, and you'll see they're exactly the same. So, you know, I do this one. Instead of pausing and all that stuff, you're going to do this one. I'm going to do this one. You're going to do this one. So I kind of do it a little different on the next page. But so yeah, page 5, number 1. Use congruent arcs to find arc measurements. So JK and LM are congruent. So LM and JK. And so the measure of arc LM, so that's over here, 75, which they gave us. They want us to find JK, the arc JK. All right, so remember a little, think back previous page, we found out that if these two chords are congruent, then the arcs made are also congruent. I'm just going to make them 2, even though it would be 1. So in this case, the measure of arc, what is that, LM, is going to be equal to the measure of arc JK. All right, should have wrote that the other way, but so that being the case, since we know these two are congruent or equal, and this equals 75, then JK equals 75 degrees. All right. All right. So as you'll see, number 2, using congruent arcs, and it says to find arc measures, we're using congruent chords. Down here it's arcs to find chord. That was right, but we were wrong there. All right, so scooching down to number 3, using congruent arcs to find chord length. So just doing it backwards, just like we always do. So they give us that DE is congruent to FG. All right, they want us to find line segment FG. All right, so if the chords are congruent, then if the arcs are congruent, then the chords are congruent. So that would put FG congruent to ED. Okay. So, sorry, got a little sidetracked. So that puts these chords congruent. So they want us to find FG. FG's over here. So FG is 5x minus 9. And then ED is this one. That's 2x plus 6. All right, I'm going to start with the 2x because it's the smaller. All right, I'm going to bring 6 down, 3x, 5x minus 2x is 3x. All right, we're going to add the 9 to both sides. 3x is going to equal 15. So we divide both sides by 3. Oops. X equals 5. All right, well, they want FG. FG equals 5x. Oops. Minus 9. 5. So x equals 5 minus 9. So FG is going to equal 25 minus 9, which is 16. All right, so number 4, you'll see, works the same way. Flip over page 6. So start at the top here. I'm going to do number 5. Number 6 is going to work the same. We got a perpendicular radius. It says radius perpendicular to a chord. So yeah, here's your radius, here's your chord, radius, chord. Same thing over there. So I'm doing here. And then next row, I'm going to do number 8. They're both diameter perpendicular to a chord. But let's start with number 5. So using radius perpendicular to chord in circles D, a measure of arc EFG. So let's just do this. Put it all under there. So EFG is all the yellow. And that's 120. The whole thing, 120. So from here to here. All right, find the measure of FG and EG. This, we'll just do, we'll say EG. Okay. Okay, so you guys remember back to the previous page when we were talking about this. That, let's see, find a different color here. So if this is perpendicular, if these two guys are perpendicular, then these arcs are, it bisects the arcs. So these two are congruent. And it bisects, it's a perpendicular bisector. So it's 90-degree angle, but it bisects. So it splits these two chords also. Let's see, hang on 1 second. Okay, so let's start with EG. So EG, that's the whole line here. It's going to equal, we can see this goes to EH. It's EH times 2 because these guys are congruent. We have EH, so EH is 3.5. 3.5 times 2 is 7, so EG equals 7. All right, so that was easy enough, right? This is even, the other one's even easier. So we want the measure of arc FG. So FG is over here. It's congruent to EG, and these two together make EFG. So it's half of EFG. So it's 1/2 of the measure of arc EFG. All right, and we know that EFG is 120 degrees. So what's half of 120? Well, that's 60 degrees. So the measure of arc FG is 60 degrees, and EG was 2 times 3.5, so it was 7. All right, so you do number 6. Scooching down the page, number 8. So I'm switching over to that because we did talk about this one in class, and I gave you the right answer, but I gave you the wrong reason, and I told you I wasn't really comfortable with it. So using a diameter that's perpendicular to a chord, that's what this is. This one's actually easier. So do the harder one here. All right, so steering devices provide drivers with more control and strength when turning a steering wheel. A technician is installing a steering wheel at point P, or it's a device, excuse me, at point P on the steering wheel shown. So right here. The steering device extends to point T. So your steering device is the red little piece right here. I know you see the box, it looks like a J. It's just the red piece from P to T. Okay? Let's see. The diameter of the steering wheel. So diameter is 15. So the diameter goes from P all the way over to Q. If a chord SV, so SV is this chord, and it's 12 inches long. It's perpendicular to the diameter of the steering wheel. What is the length of the steering device? So let's see. Okay, sorry about that. Excuse me. Okay, so we've got the diameter. So the diameter is 15. So from R, let's see, from R to P is half of that because it's the radius, so it's 7. Okay. No, I'm sorry, 7.5, because half of 15 is 7.5. Thank you for you guys that are paying attention. All right, so what is the length of the steering device? So the steering device they want is between P and T, I know. So this little bit here. So if SV, the whole thing is 12, then half of it is 6, okay? Because this is perpendicular. It's a perpendicular bisector. So this side's 6, this side's 6. The whole thing's 12, right? Okay. So from R to P is 7.5. So I'm just going to put RP right here, so we know it's 7.5. From T to P, what we're going to do, we're going to make, so R is the middle of the circle. We're going to draw a line to S. Now that's a radius because it went from the center to the circle, right? Okay, 6 belongs with that. I'm going to change colors. Actually, let's just do that and put 6 out here because that's this half of the 12 over there. Sorry to make it weird. But, all right, so this is a radius. If the diameter is 15, the radius is 7.5. Okay, so we just have a triangle here. If we can find RT, so RP, that's from here to here, and we can use that to subtract what this piece is using the triangle. So RP is going to be RT, which is what we're finding with the triangle, plus PT. That's the steering device. That's what we want to solve for the problem. All right, so we'll switch to a pencil here. So, so our triangle here, we're going to use C squared minus B squared equals A squared. A squared is going to be RT. Just put A squared right there, okay? So our C squared across from the 90-degree angle, 7.5 squared, minus the B squared, which is this side, 6, and that's going to give us our RT. In fact, I'm just going to make that RT because that's what it's going to be. So, excuse me, over here, 7.5 squared minus, so that was 56.25 minus, let's just see if I got enough eraser left. Alright, so that minus 6 squared, which is 36. So minus 36 equals, this is going to be RT squared. So it's 20.25. Now we need the square root of both of these. So square root, so RT equals 4.5. So 4.5 plus PT, that's the one we're looking for the little steering device. And RP is the radius, which is 7.5. So we're going to subtract 4.5 from both sides because RP, which was 7.5, equals RT, which we just found was 4.5, plus PT. That's the thing we're looking for, the little steering device right here. So we're going to subtract 4.5 from both sides. So it cancels here. 7.5 minus 4.5 is 3. So PT, I'm just going to write that in red. So I told you guys 3 in class, but not for the right reason. So I wanted to clear that up. All right, so getting down to the bottom here, we're going to do number 9. Number 10 is going to be yours. So these are chords that are equidistant from the center. So they told us that, so equidistant, say this 8 and this 8 belong, that means that this and this are congruent. So these chords are equidistant. And we learned that when the chords are equidistant, then the chords are also congruent. I'm just doing it like that. So PQ and RS are going to be congruent. So PQ, not arc, excuse me, chord, congruent to RS. Okay. So they tell us PQ here is 3x minus 4, and it equals RS, which is 14. See, they told us up here. So just a little different. It's put up here instead of to the side, but we put them equal to each other because they're equidistant. Then we're going to solve for x, so we're going to add 4, as they said, find x. So add 4, these cancel, 3x equals 14 plus 4 is 18. Is that right? Yes. Divide both sides by 3. 18 divided by 3 is 6, so x equals 6. Like I said, number 10 is yours. If you have any questions, please let me know. Until next time, have a great night.